Assalamualaikum. For our presentation for the production of acrylonitrile, we begin with the mass energy balance for the process first. So from the process flow diagram here, the equipment used is the reactor, quench column, absorber, recovery column, HCN column, acrylonitrile column, and also acetonitrile column. So to proceed with the calculation for the mass energy balance, we refer to the block flow diagram for all of the equipment used. From the block flow diagram below, there are 16 streams that will be calculated. The temperature for the process are from 30 degrees Celsius to 130 degrees Celsius, and the pressure was set to 1 atm for all of the streams. The composition that include in the process and recorded in the stream tables is ammonia, propylene, oxygen, nitrogen, alcohol, acrylonitrile, acetonitrile, carbon dioxide, hydrogen cyanide, water, and also sulfuric acid. The mass flow rate for all of the streams were recorded in the stream tables.
And now we move to the energy balance. The energy balance is done to get the heat of reaction in the reactor and to know the heating requirements for all the equipment. This is done by calculating the inlet and the outlet enthalpy of all the equipment, and then the heating requirement of all the equipment is obtained by subtracting the enthalpy outlet of the equipment with the inlet enthalpy. All the results obtained from the calculation are presented in the table in this slide. Based on the table, we can deduce that the equipment that requires heating are the one with negative values in their heating requirements, which are the HCN column, the acetal column, the quench column, and the recovery column. As for the equipment that requires cooling are the one with positive values in their heating requirements, which are the SEN column, the reactor, and the absorber. The values of the heat of reaction is a negative value, which indicates that the reaction is an exothermic reaction.
My name is Azi Anastasia and I will present the equipment design part. As you can see here, this is the heuristic analysis for the major equipment. The first one is the reactor. The volume is 15.27 meter per cube with the height of 3 meter with a diameter of 2.54 meter, and the table used is 11.17 rule number 9. For the distillation column, table 11.13 and 11.14, rule number 9, 2, 7, 6, 8, 5, 13, and 14 is used. The height for the recovery column is 7.114 meter and number of trays of 7.48. The HCN column has the height of 5.0926 meter with the number of trays of 3.8. Next, acetonitrile column has the height of 4.1709 meter with number of trays of 2.13. Acrylonitrile column has the height of 10.68 meter with the number of trays of 13.97. The height for the quench column is 9.7925 meter and the number of trays is 12.35. The last but not least is the absorber. The height calculated is 3.45 meter and the diameter 1.38 meter. The table used is table 11.6, rule number 3, 4, and 5.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuna Bilaliana and I would like to present about the cost calculation part. The first part for the cost calculation is bare module cost, and this is the result for the bare module cost in 2001 and 2021 for the 7 major equipment in this plant. The total for the bare module cost in 2001 is 4,209,036 ringgit and 67 cents, and for the result for 2021 is 8,134,978 ringgit and 21 cents. Next is the grassroots cost, and this is the result for the bare module cost in 2001 that we will use for the calculation in the total module cost and the grassroots cost. And the result for the total model cost is 9,599,274 ringgit and 31 cent. And the result for the grassroots cost, or we can also say fixed capital investment, is 13,665,837 ringgit. Next is cost of manufacturing, and in this table is the result for the item that we use to calculate cost of manufacturing, which is raw materials, utilities, operating labor, and waste treatment. And the result for the cost of manufacturing is 926,255,022 ringgit and 7 cent. The result for the cost of manufacturing without depreciation is 924,888,439 ringgit. Next is the land cost, which is located at Bandar Cukai Kemaman, and the price for the land cost is 801,504 ringgit. And next is the revenue per year, and the result for the revenue is 1,913,782,500 ringgit. Next is the working capital, and the cost for the working capital is 2,049,875 ringgit and 55 cent. And lastly is that we assume the estimated salvage value is 0.
For profitability analysis, the info such as the sales revenue, the cost of manufacturing after depreciation, the taxation rate, the fixed capital investment. Fixed capital investment during year 1 and year 2 was prepared in order to calculate the cumulative cash flow diagram for non-discounted and for discounted. After the calculation, the value for cumulative non-discounted cash flow and also cumulative discounted cash flow was recorded in the table as shown below. After that, the graph for cumulative cash flow versus time after the project for non-discounted and discounted was plotted. As we can see here, for cumulative non-discounted cash flow, the cash flow was increased after 2 years. And for cumulative discounted cash flow, the cash flow was increased approximately after 2 years and a half.
Next, from the non-discounted cash flow diagram, we can determine the profitability criteria. Firstly, payback period. We use the direct interpolation based on the fixed capital investment value, and we got 0.0312 years. Next, for the cumulative cash position, we got 9,785,208,827 ringgit. For cumulative cash ratio, we use the formula 1 plus cumulative cash position over land plus working capital plus fixed capital investment, and we got 593.42. And for the rate of return on investment, we use the formula slope over fixed capital investment minus 1 over n, and we got 71.61%.
Next is the discounted profitability criteria, and this is the result that we have calculated. The first one is the DPBP, which is negative 0.0061 years. Next is NPV, which is 4,902,891,724 ringgit. The next one is PBR, which is 344.0411. And lastly is a discounted cash flow rate of return, which is 345.10. From this table, we can see there is an error, which is DPBP and also discounted cash flow rate of return. And this error may have been caused because of the error in cost calculation, and also project have higher cash flow toward the end of a project life, and experience greater discounting due to compound interest. For this reason, the payback period may return a positive figure, while the discounted payback period returns a negative figure.
From the profitability analysis, the net present value calculated is 4.962 billion ringgit Malaysia. The discount cash flow rate of return DASFOR is 350, y and the payback period is negative 0.061. For non-discounted cash flow, the rate of return ROI is 71%, while the payback period is 0.0312. From the DCFROR, when compared to the value with the internal interest rate, the value of DCFROR is higher. From this comparison, it seems that the project will gain profit in the life project time because the DCFROR is more than the internal interest rate, and the value obtained is more than Malaysia interest rate, and the value almost the same as the other country investment rate, which is the country are more stable in their economy. So the project will be perfectly run in the returning of the investment and profitably. The project of production of acrylonitrile is good to carry on and continue because based on the analysis of the cash flow diagram, the project will be profitable and increase the production of acrylonitrile in the world. Thus, it is significantly relevant to continue the project.